Alrighty, perfect. So as we had discussed earlier, on the first day of classes, we're just going to record these meetings just for the purpose of anybody who's absent can always feel free to go back, or you can revisit this information. So I'll be posting these videos of our class meetings over the weekend. Essentially, if say we have our class on Monday and Wednesday, I'm not going to post them to YouTube directly after our class. It takes a little bit of time to upload the video, and generally I'm busy with something else. So I just collect all three of the class meeting videos that have been recorded and post them all over the weekend. So in this case, because this is only the first one of the week that's being recorded, I will, obviously post this as soon as I can. But for future reference, if you miss class on Monday, expect to not see it posted on YouTube until that following weekend. Okay? Okay, so we can now go ahead and start discussing the homework. Again, the first lecture, I sincerely apologize. I didn't have the tablet for the first lecture, as I mentioned before, so everything was done with the mouse, and it looked really funky and bad, and again, I apologize. But going forward, yay, we have this nice pen here in the tablet, so hopefully life is easier. So does anybody have any specific questions on the homework? Otherwise, I can just jump into a couple ones that I feel are important and a couple topics surrounding that.
Could you go over number 6?
Number 6, sure, absolutely. So number 6 has two parts, part A and B. We'll tackle both of those separately. So the goal for number 6 is we just have to provide interval notation for the solution. So the solution is given to you. You just need to write it in the proper notation. Now, if you recall from the lecture, interval notation, just to give a quick demonstration, it's going to look something like this, where the brackets aren't looking awful. Some, interval from one number to the next. And you either use brackets or you use parentheses, depending on if you're including or not including the endpoints. So real quick, before we even touch number 6, A or B, I'm just going to ask you guys, feel free to just, you can type it in the chat, raise your hand, whatever the case. Do we use parentheses or brackets when we want to include the number? When we want to include the endpoint? Bracket, yeah. Thank you, Elise, Aaron. Exactly. So the idea is you're just going to be using brackets when you want to include the endpoint, and alternatively, if you are not including the endpoint, you will be using parentheses. So these are just two quick examples of intervals, and A and B is just any real number. So we'll be looking at more detailed example here with number 6. So number 6, part A, says the numbers between -7 and 12, so positive 12, not including the endpoints, and then all numbers greater than 12. So with trying to figure out intervals and writing intervals down, it's always beneficial to give yourself a visual representation of what's going on. And the visual representation of an interval is going to be the number line. So we go ahead and just quickly put down a number line, right? So let's see. We know that the furthest to the left that we're dealing with is -7, right? We're not talking about any numbers to the left of -7, so we're just going to start at here. And we know that we're going to be talking about 12, but notice the end of the solution says, and all numbers greater than 12, right? So we're also talking about this area going to the right. Somebody, if you can just make sure that you're muted, I'd appreciate it. Thank you. So we have from -7 to 12. And so the first part of the solution says all the numbers between -7 and 12. So we're talking about these numbers. And remember, when we're trying to use the number line, you shade in the area that is part of your solution. And when you have a specific point that is part of your solution, you use the closed-in dot. Or alternatively, we discussed that you could also put something like a bracket or parentheses directly on the number line, but the notation and convention that I use are the dots, open and closed, and that's what most other people use. So first part of the solution is done. We know that we're talking about the numbers between -7 to 12. We also know that we're not including the endpoints. So remember, when we're not including the endpoints, that means you're using that means you're using parentheses or the open circles. So in this case, we're going to be using open circles. just as such, right? Open dots, because we're not including the endpoints. And then the last part says all of the numbers that are greater than 12. So 13, 14, 15, so on and so forth. So that's going to be the numbers to the right of 12. So again, all of these numbers. And so we're talking about this shaded region. Okay, so now notice that we actually have two different regions here separated by the number 12. And because there's an open circle on 12, because the direction said not including endpoints, we know that we're not including that in our final answer here. So we have this region here and that region. So for the first one on the left, who thinks that they can help me out with this? So we're talking about this one right here. Who can give me the interval for that?
Greater than -7, less than less than 12.
Okay, so again, remember we're trying to use this kind of notation, right? So we're talking about you know, parentheses, brackets.
Sorry, I missed the beginning of class today. I've been having technical issues. I thought we were on Collaborate for some reason.
Yep. Erin, I saw your hand go up if you want to give it a shot.
Yeah, so parentheses -7, comma 12 parentheses.
Comma 12 parentheses. Exactly, right? So we're talking about all the numbers between these two endpoints. So from -7 to -12, that's part of your solution. And Erin used parentheses because, again, we're not including the endpoints. So great job. So that's going to be the first interval. But again, remember, we have this other area over here that is also part of our solution. So we have to find that interval as well. Anybody else want to give that a shot?
Parentheses 12, comma infinity.
So parentheses, 12, comma, infinity. And what am I putting after the infinity?
Parentheses.
Parentheses, exactly. If you guys recall from the lecture, regardless if it's positive infinity or negative infinity, you are always going to be using a parentheses at the end of, you know, when you write this notation there. Okay, so great. So we have our two intervals. And these are our two solution intervals. And now there's just one last thing that we have to do just to kind of mush them together. So what's the missing piece here that I have to do for my two intervals? Elise? Yep.
Like the U thing?
Yeah, the U thing, exactly. Union. Yep. So this right here would be our final answer for the above solution, or for 6A. So the idea here is, again, you have two different intervals. You just write each interval as accurately as you can. And then when you're done writing each specific interval, you union them together and you're done. So that's it. So we have from -7 to 12, again, with parentheses, unioned with 12 to infinity, also parentheses because we're not including endpoints, and parentheses for infinity always. Any questions on 6A before we move on to 6B? Okay, let's go ahead and move on to 6B then. So we're going to clear this off. Again, same directions, right? Directions are just give the interval for the solution, and it's always helpful to give a visual representation. So number line, visual representation of an interval. We want all negative numbers and also all numbers that are greater than 4. So 4 is listed, right? So we know that we're going to have 4 somewhere in here. So I'm just going to plot 4 on our number line. And we also are talking about all negative numbers. So before we talk about all negative numbers and how to represent that, where are negative numbers? To the left of 0 or to the right of 0? Just not a trick question, I promise. Yeah, to the left, right? So we're talking about this area over here, right? And yes, Christopher, saw your hand go up. What's going on?
Are these all problems out of the textbook?
These are, if you recall, I work out of the 3rd edition, so these would be problems out of the 3rd edition textbook, not the 4th, which is provided by the bookstore. Or if it, I mean, it might be in the 4th, but I genuinely wouldn't know. Okay.
Okay, thank you.
Yep. So again, we're talking about all the numbers then that are to the left of 0, and then also all the numbers that are greater than 4. So that means 5, 6, 7, so on and so forth, right? So when we're shading in our regions here, because again, we're talking about all numbers greater than 4, we know we're talking about these numbers. And we want all negative numbers as well, right? So -1, -2, -3, so on and so forth. So we're talking about this area over here. So now the last question that you have to ask yourself is, okay, well, what about the endpoints? Am I putting closed circles or open circles here? So let's start with 0 and figure this out. It says all negative numbers. Is 0 a negative number? No, right? 0 is 0. It's
Definitely
not
not.
negative, it's not positive. So because 0 is not negative, we know that we don't want to include 0. So we're going to be putting an open circle on 0. And now, again, last question, we just have to figure out whether or not we're including 4. And we refer back to what the statement said. It said all numbers greater than 4. So that means 5, 6, 7. It even means, decimals, right? Like 4.1, 4.01, 4.001. It can get very, very, very close to 4, but never actually including 4, right? 4 is not greater than itself. 4 is itself. 4 is equal to 4. So we know we're going to be putting another open circle here. So the last thing that we have to do is we just have to evaluate, now that we have our correct visual representation, we just need to write it in interval form. Anybody want to give this a shot? We can start with the left-hand side first. Aaron, I'll let you go one more time. Yep. Try the left.
Parentheses, negative infinity, comma, 0 parentheses.
Perfect. And Maggie, saw your hand go up. You want to try the right-hand one?
Yes. Parentheses 4, comma, infinity, comma. Parentheses.
Yeah, exactly. Perfect. And Maggie, finish it up. What am I putting in between my two intervals, my solution intervals here?
Union.
Union. Yeah, just the U, right? And that's it. We're done. This is our final answer here. From negative infinity to 0, not including 0, unioned with 4 to infinity, not including 4. And again, as a reminder, we use parentheses because we're not including those endpoints, and we use parentheses for the infinities because you always use parentheses for infinities. Any questions with this one? Okay, cool. Anybody have any other questions on the homework? So that was 6A and 6B. Anything else that maybe gave you guys a little bit of trouble? Monique?
Yeah, can you quickly go over number 5?
Number 5, sure. Yeah, number 5 is a little tricky, and no problem, Katrine. It happens to the best of us. So for number 5, number 5 is basically just establishing, your understanding of transitivity. So transitivity, just using 3 quick numbers. Remember, if 3 is less than 4, which we know is true, and 4 is less than 5, then by transitivity, you know that 3 is less than 5, right? And we can replace numbers with variables. So if you know that A is less than B, and also that B is less than C, then you know for free by transitivity that A is going to be, that's supposed to be less than, that A is less than C. Okay, so this is just transitivity, and number 5 is basically just questioning your understanding of that. So let's write out all of our information. First off, the question is asking you what the inequality relationship is between D and E, right? So we have D, we have E, and then we're trying to find out what's going on between them. Is D greater than E? Is it less than E? Or is it equal to E? If you guys remember, by trichotomy, there's only 3 possible options, right? It's either less than, greater than, or equal to the other number. So we're trying to figure out what the relationship is between D and E. And right now, I'm just going to leave it as a question mark. So let's write out all of our information. And I'm just going to leave this at the top because that's what we're shooting for. That's our goal here. So our information that's given to us is A is less than B. That's the first piece. The next thing is C is equal to E. But does this help us with A is less than B? No, it really doesn't help us at all just yet, because notice that for this first one, the only 2 variables that we're using are A and B, and neither A nor B are in this equality. So that second piece of information isn't going to help us out too much just yet. The third piece of information that we're given is D is going to be less than A. And then the final piece of information here is B is less than C. So what we're going to try to do here is we're going to try to essentially chain everything together. We're going to take one piece of information and apply it on top of the next piece of information where the variables match, right? So let's start with A is less than B. Who sees the other next piece of information that is going to help us, further along the chain? So we have A is less than B. We're looking for another piece that has either A or B with it. Yep, Hayden.
It shows that B is less than C and C is equal to E. So you could change it to B is less than E.
Okay, so say that one more time for me. So we have A is less
Yeah.
than B, and then you also
Right.
said, what's the next piece?
B is less than C.
B is less than C, yep. So that is using this piece of information here, right? So we know A is less than B and B is less than C, okay? And then keep on going for me.
And C and E are equal to each other.
Yeah, C is equal to E. So that means, just like you said, we can replace C with E, right? So this is really the same thing as A is less than B is less than E. Great.
And D is less than A.
And the last piece of information here, which ties into our goal, right? We're looking for the relationship between D and E. So it should make sense that we're, still trying to figure out where D goes. And because D is less than A, we know that we can throw it right over here on this side, right? So D is less than A. So D is less than A is less than B is less than C, but we knew that C was actually equal to E all along, right? So we can replace the C with the E instead. So now we have D is less than A is less than B is less than E. And because, again, we're looking for this relationship right here, what does this tell us by transitivity? What is our final result? Katrine? Yep.
That D is less than E.
Yeah, that D is going to be less than E, right? If D is less than A, is less than B, is less than E, then D is, the first number is going to be less than the last number in that sequence, right? So our final result here is D is less than E. This one you're not going to see this too often. Questions like this aren't going to pop up many times, but it's just understanding how to chain pieces of information together. We started with one piece of information, which was the A is less than B, and then we just looked for the next piece of information that goes along with the chain, right? So if A is less than B, and we're dealing with transitivity here, we're just seeing the next inequality that could possibly tie in. Any questions with this one? Just want to make sure we're all good with this.
Little puzzles like this can actually help you build your memory and your logical side of your brain. If anybody has trouble memorizing formulas, this is one of the best ways. Do little puzzles like this.
Puzzles are good, indeed. Katrine, I just want to make sure, was that hand up from before, or is that just a question now?
Sorry, that was from before.
Okay, no problem. Okay, so I take it we're all good with this, and I can move on. Alrighty. So, any other questions regarding this particular homework? Okay, so I just want to jump into question 3. Just want to make sure that we understand order of operation. And then after question 3, if there's no other questions on the homework, we're just going to tie in a couple other questions that I have for you guys based on the lecture. Okay, so question 3 just says evaluate, which basically just means give the number back, right? Do the operations, see what happens. So the following evaluation is on. We have 3 plus -1 plus 4 divided by 2 minus 1 times 3 times 2 plus 2. Okay, so for this one, we have to look at order of operations, right? This is probably, in lecture 1, this is probably the most important thing for the rest of this class, because if you don't understand order of operations, you're going to have a very, very difficult time when the material actually starts getting tricky. So for right now, order of operations, right? We know it as PEMDAS. And I'll write it one more time. The acronym PEMDAS, where each letter stands for something, right? So P, parentheses, E, exponent, so on and so forth. Yes, Christopher.
Don't we do exponents on parentheses first, though?
So we'll see what happens when we tie in exponents. Exponents are going to come in, I believe, in the next lecture. So that'll hopefully answer your question then. But yeah, when we have exponents on parentheses, so let's say we have a plus b squared, then you're handling the exponent here via some sort of distribution. Again, we're not going to get too bogged down in the details right now because that'll be for a later lecture, but there are ways to handle it. So good question. Just keep that in mind and we'll revisit that.
Okay, thank you.
Yep. Okay, so PEMDAS, right? And again, this, when you read it from left to right, you're reading it in the order that you should be doing things. Now, there's one caveat to this that you should be aware of. Multiplication and division have the same order of operation, which means that you don't do them, at some random order. You do them reading from left to right. So if there's multiplication and division inside of one equation or one expression, you just do the order, you do the operations reading from left to right. And the same is also true for addition and subtraction. You do it reading from left to right. Now, in general, we'll see that sometimes that might not matter, but specifically with multiplication and division, we'll see situations where that actually does matter. Okay? So for this one, again, keeping order of operations in mind, who can tell me what the very first thing, and there's technically two right answers, what the first thing is that we're going to be doing here? Yes, Christopher, one more time.
I would do 4 divided by 2 because it's in the first parentheses. Going from left to right, I always do the first parenthesis first.
Yeah. So again, you're reading this expression and there's a whole lot going on, right? We have addition, we have a negative number, which, subtraction, we have multiplication, and we have division. So it might look a little daunting at first, but you just have to break it down, right? So we know that by PEMDAS, the first thing that we're doing is we're handling parentheses. So you can either drill down into this parentheses or you can do this one. It doesn't matter because they're both parentheses and regardless, we'll come out with the same expression either way. Okay, so as Christopher said, we're going to drill down into the first parentheses. That's a totally fine way to go. So that's going to be this one. And we see that we have a division and addition going on. Well, by order of operations, we do division first because division is higher. It's preferred, right? So we have 4 divided by 2. So when we simplify this, I'm just going to bring everything else down. We have 3 plus -1 plus, and we have 2, right? 4 divided by 2 gives you 2. Then we have -1, and in the same step, I'm just going to do the next parentheses as well. So in the next parentheses over, we have inside of it 3 times 2, right? So we have -1 times 6, and we still have the +2 over here. Okay, well, we did some stuff. We condensed it. We got rid of some of the operations going on. Let's keep going, right? So the next step, again, is to handle parentheses, right? So we have this -1 plus 2 going on right in here. So I want to take care of this parentheses so that way we can continue onwards. So we have 3 plus, I'm just dragging down everything else that I'm not touching. And then we have -1 plus 2. Another way that you can think about it is 2 minus 1. However, in your brain, you can come up with the right answer. And we end up with just the 1 there. Then we have -1 times 6 plus 2. So again, with every step, we see that we're getting closer and closer. We're getting rid of operations. And we just have to figure out the last thing here. So again, going through this, who can help me? What's the final operation that we're going to do first before we get to any of the other ones? Nico, if you want to help me out.
You do the -1 times 6.
Yeah, -1 times 6, right? So we have this -1 here, and it's being multiplied against the 6. We see that the other operations are addition and subtraction, right? So we're not going to mess with addition and subtraction until we get through the multiplication. So getting through the multiplication, we have 3 plus 1. Again, I'm not touching those numbers. Those are just dropping down. Then we have the -1 times the 6, which gives us -6. Plus 2. And now because addition and subtraction are on the same order, we can just read it from left to right and go across. And we see that we have 3 plus 1 gives you 4, minus 6 gives you a -2, plus 2 gives you 0. Any questions on this? Again, just to quickly recap what we did. We saw that we had parentheses, so we dived into the parentheses just to get going. Inside of the first parentheses, we saw that we had division and addition, so we did the division first. And then we handled the rest of the parentheses. So we had the -1 plus 2. We also did the multiplication of the -1 times 6 ahead of the subtraction or addition. And then when all we had left was addition or subtraction, we just did it all reading left to right. We ended up with 0. We good with this? Okay, cool. So if no questions on that, if we're all good, then just pulling some other stuff here. These are questions, again, that I just had prepared that relate to the lecture. They were not on your homework, so don't feel like you missed anything. So I feel like with the foundations, when we're learning or reviewing foundations, it can often be very beneficial to try to find other people's mistakes. So here's some mistakes that were actually made by other students. So these are things that, I've seen before that I'm just going to put on you guys and see, okay, can you find the mistake? Where is the mistake? Okay, so let's say we're starting with here the interval, and I'm just going to draw the number line first. So we have -3, we have 2, and let's say we had closed, closed dots on these, and we're talking about the interval from -3 to 2, right? And I saw from a student when they were writing their answer, they wrote it as the following. So for this specific number line, they wrote their final interval solution as this. Okay, so there's actually 2 mistakes here. So who can tell me one of the mistakes? And again, the mistake is going to be with the interval notation. Okay, saw a lot of hands go up. I'm just going to pick on somebody I haven't picked on today. Raven, if you want to help me out.
Wouldn't -3 go first?
Yes, exactly. So the first mistake here is that we always want to write our intervals from the least to the greatest. So if you guys recall, when we were writing our intervals dealing with -infinity, we always wrote it -infinity and then whatever the other number was, right? So we write the numbers from lowest to greatest in that order. So writing it from 2 to -3, well, that's not going to be correct. So we're going to go ahead and flip this. So we know that we have from -3 to 2. Okay, so that was the first mistake. And then there should be one more here. So who can tell me the next mistake here? Carly, if you want to help me out.
The first parenthesis should be a bracket because you're including the -3.
Exactly. So we see here that this is a closed dot, right? So this is on our number line. We're supposed to be including the number -3. So as a result, that should not be a parentheses. This should be a bracket. And so this is now the correct interval. Great job. So those were the first 2 mistakes for the first problem. Fantastic job. Okay. So next up we have, and again, the next 2 problems are all just going to be regarding intervals. So we have this number line here again, where we're dealing with -infinity to 0, right? So from -infinity to 0. And we are including 0 here, so I'll put a dot, right? And this person wrote their interval, their final interval solution as, okay, what is the problem here? Okay, and Emily, Maestra. I'm definitely going to get that wrong if you don't correct me now.
It's Maestra.
Maestra? Okay, great. Okay, so what's the problem with this interval here?
It's supposed to be a parenthesis for -infinity.
Yeah, exactly. Whenever we're dealing with infinities, be it positive or negative, you're always going to be using a parentheses. Exactly. Great job. So that is fixing that one. And one last one for trying to find the mistake here. So we ended up, by some happenstance, we ended up with this very particular number line. So we have -3 over here, we have +3, -1, and we end up showing through whatever the example was that the endpoints -3 and 3 were not included. Again, open circle, and we saw that we actually had this -1 being included. So we had this interval here. Okay, this person, the student, put their final interval solution as from -3 to -1, union with -1 to 3. Okay, what is the problem with this? It's a small problem, but it's technically a problem. Okay, Hayden, one more time.
In the second part, after the union, it should be a bracket, not a parenthesis in front of -1.
Oh, that's just bad handwriting on my part. That actually already is a
I'm so
bracket.
sorry.
No, that's entirely on me. Again, you guys are gonna absolutely get very tired of my handwriting very quickly. But yes, so that actually already is a bracket. So we still have a problem here though. Anybody know what it is? Katrine, want to give it a shot?
The second section, can it start with the -1 or no?
What do you mean start with? So you're talking about this interval right here?
Yeah. Oh wait, you don't need the U, dude. Oh wait, actually no, I don't know. I'm sorry.
No, you're right. Keep going. So why don't we need the U? Why don't we need this?
Because there's no break.
Yeah, there's no break. There's no hole in the interval. -1, if we just take away this closed dot real quick, -1 is already being included in this interval, right? Putting this dot here, the closed-in dot on -1, is actually superfluous. It's extra. It's unneeded, right? It's already implied that -1 is part of the solution because it goes through -1, right? So we can actually just rewrite this interval as from -3 to 3. And that's it. That's our final interval. We don't need this, two separate intervals here with a union between them because it's essentially just one large interval. Does everybody understand what's going on here?
Yes.
Yes. Okay, good. Okay, so one more question regarding this. So can we do the same thing if the interval were slightly different? So that was the interval from -3 to -1, including 1, union with -1 also included to 3, right? If we instead had this interval, so from -3 to -1, union with -1 to 3, can we do the same thing? Or do we need the U? Do we need the union? So again, just to do a quick visual representation before I pick on somebody, because I've been doing it this whole time. Sorry about that. So we have from -3 to -1, and then the 3 over here, right? So we have open circle, open circle, open circle. We're talking about from here to here, and from -1 to 3, right? So again, my question for you, can we condense this this interval here? Yes, Erin.
No, because -1 isn't included. It's because it's an open circle and parentheses, it's not included, so we can't actually condense it.
Exactly, right? So -1 is a break in this interval, right? If this hole at -1 didn't exist, so hypothetically, if I, just erase it real quick, we see that it's just one continuous interval, right? From -3 to 3. But the problem is that we don't want to include -1, and we know that because of the parentheses, right? We see that we don't want to include -1, so we actually do need two separate intervals. We have this interval here from -3 to -1, and then we also have this interval from -1 to 3. And obviously, if we have two separate intervals, we're going to need a union between them. So great job. Any other questions regarding this? Are we good with this one? Okay, great. So let's move on to transitive property review. So just one quick question with this. So let's say I gave you this following information. So let's say if x is less than y, that's an x, I promise. So if x is less than y, and also z is less than y, then x is less than z. Is this correct or incorrect for the use of transitivity? Maybe somebody other than Christopher and Katrine? Maggie, you want to go again? Sure.
It's correct.
It's correct. Okay, so we have x is less than y, right? So we're just going to rewrite this. So x is less than y. And then we also have that z is less than y, right? But how do I write this as part of the chain, right? If you remember from the homework question, we tried just creating one large chain. So how would I try to continue this chain here if z is also less than y? Okay, Hayden, I saw your hand go up.
Can't you not really make a chain because you don't know the value of x and z?
Yeah, so we see here that x is less than y, and z is also less than y. But does that give us any information regarding x and z? No, right? We can't really come up with any sort of evaluation between those two numbers. Let's use actual real numbers instead of variables here, just to give a quick example. So I always use 3, 4, 5 as my my go-tos, right? So just to plot this in again with real numbers, we can say, okay, so hypothetically, if 3 is less than 5 and also 4 is less than 5, does that prove that 3 is less than 4? No, right? All you did is you just show that two numbers are less than another number. You haven't showed any sort of equivalency or relationship between these guys, right? So because again, you can't really build a chain. And if we saw from the homework question that we just went over that that's the entire point, right? When you're trying to use transitivity, you're just trying to build a chain with all the information that you have, right? So we have 3 is less than 5, but then where is the 4 going to go, right? So where is this going to end up in our chain? And the answer is, oh yeah, it really doesn't. We can't build a consecutive chain here. So as a result, okay, yeah, we can't use the transitive property to say anything about 3 and 4. Now, obviously, because we know these numbers, and we obviously know 3 is less than 4, you can just use intuition here to say that and decide that. But it's not the correct application of the transitive property. So again, just be mindful about how you're trying to build the chain, right? Again, we started with the first piece of information that x is less than y. So we have this. And then the second piece of information is that z is also less than y. But again, notice this is now starting a completely different chain. So we can't get any sort of relationship between x and z. Does that make sense? Are we all good with this? Okay. Okay. And again, if something doesn't make sense, Katrine, is that a new hand raise? Sorry. No? Okay. If something doesn't make sense, please, of course, feel free to just talk with me about it after class or in email, and we can always go over it. Okay? All right. So the last thing that I want to talk about today, again, just really hitting on the importance of PEMDAS, order of operations. We're going to go through just two really quick problems. So these are two problems that you might actually have seen on Facebook. When you see those like the really like massively shared, like, hey, get the number, and then everybody's arguing in the comments. Also, I feel like I probably just dated myself. Does anybody even use Facebook anymore? Maybe? No? Okay. So we have, for example, this. You do? Great. Awesome. Okay. So we have 7 plus 7 divided by 7.
I use Messenger. Does that count?
Sure. Plus 7 times 7 minus 7. So again, this is something that you might have just seen online already because it's a super popular problem. And it definitely trips a lot of people up because people in general might not understand order of operations. Also, I just made a boo-boo. We don't want to use x, right? We want to use the dot when we're talking about multiplication here. So 7 plus 7 divided by 7 plus 7 times 7 minus 7. Okay. So there's a lot going on here, a lot of 7s, right? We have to figure out the accurate, correct way to approach this problem. So we have addition, subtraction, division, and multiplication. So using order of operations, what is the first operation that we're going to tackle? What is the first one that we're going to do here? Kirsten, if you want to help me out.
Multiplication.
Okay, so 7, we have the 7 times 7, right? So that one, right? But remember that multiplication and division are on the same order, right? And since they're on the same order, we're reading from left to right. So what else could we also do ahead of time? We could also do this 7 divided by 7. Now, it really won't matter because again, as long as you do them, either at the same time or, one followed right by the other, that's totally okay. So we can definitely do what Kirsten said and do the multiplication first. So doing the multiplication first, and let me just use different colors here. Doing the multiplication first, we see that we have the 7 times 7, which gives us 49, right? So we have 49 dropping down. Any other numbers that I'm not touching, I'm just going to go ahead and just bring them down. So I have that first 7 plus, and I have this minus 7, again, just dropping things down here. And then again, we have the 7 divided by 7. Remember, order of operations, right? Division comes before addition or subtraction. So we have to do the division first. So 7 divided by 7 is going to give us 1, right? Any number divided by itself gives you back 1. So now we have 7 plus 1 plus 49 minus 7. And we see that when you read it, from left to right, you get 8 plus 49 minus 7. 8 plus 49, well, that should give you 57 minus 7. And then 57 minus 7 gives you 50. Now, we're going to see that addition is actually going to be commutative. Commutative means that you can move things around when you have addition or subtraction, which means that the order in which you add or subtract doesn't necessarily have to be from left to right. What I mean by that is if you saw that you have this positive 7 and negative 7, you can just cancel those out, and then you're just left with the 1 and the 49 remaining, and 1 plus 49 gives you 50 either way, right? So because addition is commutative, we get the same answer regardless how you think about it, but reading from left to right, we still get 50. The important thing to take away from this is, again, just noting that we're doing multiplication and division before addition and subtraction. Any questions on this? Okay, so one last problem, and then that'll be it for today. So last problem here, again, still same thing with order of operations, right? So we have 6 being divided by 2 times 1 plus 2, and we want to evaluate this. Now, for the record, this one is purposely ambiguous. There's 2 answers that you can commonly get. One of them is definitely going to be more correct than the other one, but it's understandably ambiguous, and we'll see why in a second. So first off, let's just do it the 100% correct way, which is, using order of operations, just like we've been talking about, to establish what comes first. So remember, order of operations is PEMDAS. What is the first letter? P, right? P is parentheses. So we know that we want to be dealing with this piece first, right? The 1 plus 2 in the parentheses, that's going to come first. Hayden, did you have a question, or was that just because I kind of asked a rhetorical question?
I didn't even realize I clicked it. I'm so sorry.
Okay, no worries, you're fine. Also, Olivia, sorry I'm reading your message so late. Is there a place we can find a practice sheet on those? Are you talking about transitivity, or are you talking about the order of operate? Probably transitivity, right? Because that was 5 minutes ago. I would wager there's probably something online. I can definitely take a look for you. I don't have anything like that prepared, like a practice sheet on transitivity, but I can probably come up with something for you. So just getting back to this, again, we have the 6 divided by 2 times 1 plus 2 in parentheses, right? So because we're dealing with parentheses first, we're going to take care of this. So we're going to drop everything else down that, we're not touching, right? So we have the 6 divided by 2, and then we have 1 plus 2 in parentheses, which gives us a 3. Okay, so now we read this from left to right because, again, multiplication, which is going on between the 2 and the 3, and division, which is going on between this piece, the 6 divided by 2, well, they're on the same order, right? Multiplication, division, you can do, on the same order, but we want to read it from left to right, so that way it's as accurate as we can get it, right? So reading from left to right, we have 6 divided by 2. So 6 being divided by 2 gives you 3. And then we still have this multiplication of 3 going on. And so we have 3 times 3, which ultimately gives you 9. The reason that this is purposely ambiguous, and why you will always see a comment war on Facebook whenever one of these pops up on your timeline, is because of the fact that a lot of people treat 6 divided by this expression here as parentheses. And this, if you add those set of parentheses, would look like 6 all over 2 times 1 plus 2, right? So notice how the inclusion of an extra set of parentheses will change the appearance of this, and we'll see it's actually also going to change the outcome. So notice doing it this way, when we didn't have those parentheses, we ended up with a 9. And now, just to do this again, but this time with the set of parentheses on the outside of the 2 times 1 plus 2, we see what we're going to get is a different number. So again, you deal with parentheses the same way. You do it first. So we have 1 plus 2 inside the parentheses. This gives you 6 being divided by 2 times 3. And we know that 2 times 3 on the bottom gives you 6. So we have 6 over 6, and that gives you 1, right? So again, we have 2 completely different answers. We have 9 and we have 1, and you might be wondering which one is actually the correct one. And the more correct, or totally correct, depending on your outlook, is equals to 9. The reason, again, is because this set of parentheses wasn't here. And you want to read things as literally as you can. So you're reading it, again, from left to right. You're reading it in the order of operations. So, parentheses first, then exponents, multiplication and division, so on and so forth. And you're not adding parentheses when they don't exist. So the addition of the parentheses led to all the work on the right, but without it, we get the work on the left. Yes, Erin.
So if we put 1 as the answer to the answer to this question on a quiz, would you accept that answer, or
I would never give you anything nearly as ambiguous as this. There will always be a clear-cut answer.
Okay.
So you don't ever have to worry about that. For the record, if I ever did this, I would definitely not be aware that I did this. And when grading, I would say, oh, wait, I definitely messed up. This is definitely way too ambiguous for a quiz or, any graded material. And then I'd probably just give you guys the points for free, regardless if you got 1 or 9. But yeah, good question. Again, Yep, absolutely. The main thing that we're hammering down here is, again, order of operations, reading left to right, doing the operations in the correct order where, things have a higher tier of preference than others, where you do parentheses over multiplication and division, over addition and subtraction. And again, you want to read things as literally as you can, because as we see here, just the addition of one other set of parentheses drastically changes our answer from 9 to 1, and that's no good, right? Any questions on this? Okay, so with that being said, I'm going to go ahead and end the recording now. That's it for today's class. Just be advised that your next lecture is going to be up tonight with your accompanying classwork and homework, and then just, get through it at some point. We'll discuss it coming in on Monday. Okay? And
I have a question about homework.
Sure. Yes.
I don't have a book and I don't have access to it. And I'm pretty good with most of this stuff because I actually have passed pre-calculus already. Mm-hmm. It's just like I said, the logarithms and stuff, but I would still like to review it. Is there an online free access to anything? I mean, I could go on Khan Academy, I guess, and just do some problems on there.
I mentioned a couple resources that are at your disposal. Khan Academy is definitely a great one. There's also a couple YouTube channels that I could recommend as well that are fantastic for going over the foundations of algebra. But as far as the textbook is concerned, again, nobody really has to concern themselves with buying the textbook unless you want to have that extra tool. All of the homeworks, although I'm pulling them out of the 3rd edition of the textbook, you won't need to have the textbook to view it because I'm posting it on Blackboard. So
okay.
Yeah, all of your homework questions are right on Blackboard, found in the content area, along with everything else.
I was having an issue with Blackboard for a minute today. I think it's my network.
Okay, so again, I'm ending the recording here right now.